take 10 components now, and each of the component can be either in the up or down state. The possible number of states that we can get will be 10 to the power of 2, and that is 100. And imagine in the power system, we have about 100, 200, 300 components easily. And we take that to the power of 2, the number can be unimaginably large for us to handle through a hand calculation. Therefore, we resort to Monte Carlo simulations and just plug in all this data into computers and let it calculate. So that is the essence of Monte Carlo simulation. And it's a powerful tool, right, that power system engineers use. And it is not just applicable in power system, it's applicable in any part of our daily life. If you want to perform any analysis that is too complicated to handle by hand, whereby the interactions between the system are very complicated. Okay, we just know that this component happened, this event happened, that event happened, event 1 happened, event 3 happens. So all these individual events, they are interacting with each others, and they are all interacting between an ecosystems, and then their interaction will produce an output. So if we want to do hand calculation and consider all these interaction one by one, specifically, then it will be very difficult for us to handle by hand. And if we are able to do that, most likely there will be mistake in that. So therefore, we use simulation. We just plug in all these events, okay, into the ecosystem and run the rules of the ecosystem. So the rule of the ecosystem in power system is power flow. The rule of the ecosystem in other types of system could be other things, right? So therefore, Monte Carlo simulation is sometimes also known as the agent-based modeling. Okay, maybe you might have encountered this before. So all these events are agents. Okay, all these events are agents, and then all these agents are interacting with each other through a rule. Okay, a set of rules, and then through this set of rules, then we obtain a particular outcome based on the agent that we obtain. So the same here in power system analysis through Monte Carlo simulation. So from this analysis, then we extract information. So one of the information that we can extract is called SAIFI, System Average Interruption Frequency Index, defined as the total number of customer interruptions divided by the total number of customers served. So this is one of the measurements that we can use to determine the health of our power system. So another one is called SAIDI. Then you can go through the definitions, KD, customer total average interruption duration index, SAIFI, ASI, and so on and so forth. All right, and so on and so forth. So all these are what we call power system indices. Okay? Indices is the plural for index. Right? We use this to determine the health of our power system. So not too much of details of power system reliability that I am discussing with you, but it is also a topic that I need to cover with you, so I can let you know that there will not be any tests or assignment coming out from this chapter, but they might come out in the final exam. I do not know, right? Well, I know, but I cannot let you know. So with that, we finish the lecture series on power system reliability. It's just a touch and go, okay, kind of lectures on power system reliability, because it's a huge topic, but it's only a part of this course. So with that, I hope if you have any other questions, feel free to contact me anytime. Drop me an email, WhatsApp me, or whatever, and I'm more than happy to answer your questions as soon as I can be. So thank you.